Okay, here's video lesson 11.2 for Algebra 1. We're going to be multiplying and dividing rational expressions. 4 boxes for us to consider here today. Okay, so let's just dive into this. Let me show you an example of what we're going to be doing. When we multiply two fractions together, you may recall, you just multiply straight across. There's nothing tricky about it. So this is negative 12, and then when I multiply two bases that are the same, we add their exponents. This is going to become x to the fifth. And that's all there is to it. There's nothing more than that. So when we multiply fractions, we multiply them straight across. We do the same thing with rational expressions. Same thing here for part B. If I want to multiply these two fractions together, I just multiply straight across. So this is going to be an x minus 7 times an x minus 5, all divided by x times an x plus 3. This is factored form. Notice that everything has been factored. There are no common factors in the numerator and the denominator, so therefore it's totally fine just to leave it like that. There's nothing wrong with the way that looks. You are welcome to leave it in factored form. The more challenging stuff comes when we have to do something first. So the basic idea for multiplying rational expressions is just multiply straight across, just like you would with a normal fraction. Okay, let's try box 2. Sometimes we have to use some factoring first. So what I mean by that is what we're going to want to do is factor each piece independently. So this is like the top left piece, this is the bottom left piece, this is the top right piece, and this is the bottom right piece. If we consider 4 separate pieces, then we're going to want to factor these individually first. So top left just stays as an x plus 5. Bottom left becomes 7 times an x minus 3. Top right becomes a 7 times 2 times an x. I'll show you why I did that in a second. And then the bottom right is going to become x and an x, probably a 5 and a 2, a positive and a negative. Okay, now that I have factored each individual piece, we have earned the right to cancel. So this whole term and this whole term create a factor of 1, therefore they are allowed to cancel out. This entire 7 and this entire 7 create a factor of 1, therefore they're entitled to cancel out. Okay, that's it. What I'm left with is x on the top divided by an x minus 3 multiplied by an x minus 2. This is as far as you can go. We are not allowed to cancel an x with an x or something like that where we go reach inside the term. This is as far as we can go. So we are not allowed to cancel. If I have x over like x plus 3, I'm not allowed to cancel those because I am adding these things together. And that's what you're doing in here. You're adding or subtracting inside the parentheses. So that right there is our final answer for factoring first. Box number 3, dividing, is no different than multiplying. All you have to do is flip the second term. Because remember when you were a kid and you learned if I have 1/3 divided by 2/7, it's the same thing as 1/3 multiplied by 7/2, and then you just multiply as normal. We do the exact same thing with our expressions here. So this becomes x squared minus 25 divided by 4x plus 28 multiplied by x squared plus 9x plus 14 divided by an x minus 5. Now from here, we do exactly what we did before. We factor and cancel. Top left becomes x plus 5 times x minus 5 because it's the difference of 2 squares. Bottom left, I can take a 4 out, and I'm left with an x plus a 7. Top right, I can factor this quadratic trinomial to x and x, 7 and 2, everything is positive. And then bottom right is just an x minus 5. Now we've earned the right to cancel what is equivalent. So x minus 5's go away. X plus 7 and an x plus 7. And that's all that I can cancel. So what I'm left with is an x plus 5 on the top multiplied by an x plus 2, all divided by the number 4. and I am allowed to do that. By the way, we want to make sure that we're stating any excluded values from this. So we look at our denominators and we say x cannot be a -7, x cannot be a +5, and x cannot be anything where the numerator or the denominator would give us a 0 from that. So make sure that if it asks for that, you're also putting that in. Okay, box number 4, we're simplifying a complex fraction. So again, I want you to recognize that this is nothing more than a fraction divided by another fraction. So right away, we're going to change this into 1 over x minus 2 multiplied by x squared minus 4 over x plus 3. Once we've done that, we factor each part. 1 over x minus 2, that doesn't change. This becomes x plus 2 times x minus 2 because it's the difference of two squares. And this becomes an x plus 3. So actually the only term here that does cancel out is the x minus 2 and the x minus 2's. So I'm left with an x plus 2 in the numerator, all divided by an x plus 3 in the denominator. X is not allowed to be a 2 or a -2 or a -3 in this case. So anytime that your denominator could be a 0 anywhere in the problem, we do not let it be part of the solution set. All right, that's it.